numerical modeling, knowing the shape of the graph of trigonometric functions is necessary, basically, if we're using trigonometric functions to model. So let's try to recognize the shapes, and here mostly approximately, right? And so I start with cosine of 5x, knowing that basically cosine of 5x and cosine of and starts at, if I plug in x equal to 0, I will get cosine of 0, which is 1. And so I know the start point. I know that the magnitude in here is 1 also. I need to find a period. So 5x equal to 2 pi gives me x is equal to 2 pi. Fifth means that every max is going to be repeated after 2 pi fifths. So knowing that every max is going to be repeated after 2 pi fifths, and every min is going to be repeated after 2 pi fifths, when we add 2 pi fifths to the input, basically, and not anything earlier than that. And so I start basically, and there's no negative sign in here, so I'm assuming starting at 1 for 0, and basically it goes down, it comes back up, and that's a maximum, so I have to add 0 plus 2 pi fifths, and again repeats. Or you can subtract the negative 2 pi third over here, but beside the point, I can see that A actually matches that. Now let's try to do cosine of 5x minus pi. If I plug in x equal to 0, I will end up with cosine of negative pi, which is going to be equal to cosine of pi. It's negative 1. And then let's try to draw this. And remember the period, again, by solving 5x equal to 2 pi, I get x equal to 2 pi fifths. And I'm starting from the bottom, negative 1. And I'm going up and down and back again to the minimum. And so this should be 2 pi fifth again. And so that one is going to be over here, B. Now let's try to do tan of, sine of x over 5. And in this case, if I plug in x equal to 0, I get, basically, I get sine of 0, which is 0. And then x fifth equal to 2 pi gives me x is equal to 10 pi. So I'll start again from 0, and this time around I'm going to go up, down, back up again, and this should be 10 pi. And it repeats in the other parts. And that would be actually C. Now, let's remember tan of x, this is the parent function tan of x. And we drew that by plotting, and it looks like this function. So that one is D. And arctan should be basically, it's going to be the main branch of tan, which is that one. And so you take the main branch of tan, and then you basically reflect that over y equal to x, and everything goes the other way around like that. And so E is the answer to arctan.